Okay, well, we've got our electron diagram here for nitrogen in its ground state, and now what we want to do is show what happens to these orbitals during hybridization. So if it's sp2, we've already determined it's sp2 hybridization. That means that 2 of the p orbitals are going to be involved in hybridization. So we've got the s and 2 of the p orbitals. So that means 3 hybrid orbitals altogether. These are sp2 hybrid orbitals. Okay, and it also means that one of the p orbitals is not involved in hybridization. So we've got electron there, 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 and we have an electron there as well. And so what we want to do here is just sort of think about what else is going in these orbitals. Well, we know from the diagram that there's a double bond to one of the oxygens. We're not going to worry about resonance just yet, so just think of this is a double bond and this is a single bond. So this double bond means that there's a sigma bond and a pi bond. Maybe we should write this in. There's a sigma bond and there's a pi bond. That's what a double bond is. And this would be a sigma bond. Okay, so if you think about the valence electrons around the nitrogen, we've got a lone pair, 2 sigma bonds, and a pi bond. Okay, well, let's do the pi bond first because it's kind of easy. So the pi bond to the oxygen. Here's the electron from the nitrogen, and here's the electron from the oxygen. Okay, so this is our pi bond. And then we've got 2 sigma bonds, each to an oxygen. So I'll probably use a different color here. Well, I've already used black, so up here. So here's an electron from one of the oxygens, and here's an electron from the other oxygen. I'll do it a bit darker so it's obvious. So these are sigma bonds to the oxygens. Right here, the orbital that was full before and is still full, this is the lone pair. Now here would also be a good time to talk about resonance. Notice that we could have drawn the double bond to either of the oxygens. And then what we find in the lab, in the experiments, is that this double bond is not as short as we would expect a double bond to be, and this single bond is not as long as we would expect a single bond to be. The actual bond lengths are intermediate between a single and a double bond. So this is what's called a resonance hybrid. And so we would write that, we would indicate that as, let's do it over here to the side, when we do a double bond to that oxygen, as we've already done, and then we draw a double-headed arrow, and then we show a double bond to the other oxygen. And it's important to point out, we're not saying that the double bond flip-flops from one oxygen to the other. We're saying that the actual bonds are kind of a hybrid of both a single and a double bond.